Hello and welcome to Tribe Topper. In this video session, you are going to learn about factors affecting the resistance and resistivity. So, what can be the factors that affect the resistance of a conductor? Now, we know that electrons they are flowing through a conductor, and the main cause of resistance is the collisions of these electrons with the walls of the conductor. Now, if the length of the conductor is going to be longer, they will suffer greater number of collisions. So obviously the first factor that should affect the resistance would be the length of the conductor. And I would say that resistance R of a conductor is directly proportional to the length L of the conductor. Bec- that would mean longer wire has a greater resistance. Right. Number two, if the conductor is thicker, so obviously there will be more space for the electrons to move around. So as compared to a thinner wire or a thinner conductor, in case of a thicker conductor, the chances of collisions will reduce. The number of collisions will reduce, and so the resistance would also reduce. Hence, we can say that resistance R of a conductor is inversely proportional to the area of the conductor, which we can call as A. So that's 1 upon A. That would mean that if a wire is thicker, the resistance would be less. So thicker the wire, lower the resistance. You might have seen in your house a few of the electric appliances like your laptop charger. It generally has a thin and a long wire because the current requirement for a laptop charger is very small. So in that case, the resistance should be high, and in order to have a higher resistance, the wire should be longer and thinner. Whereas in case of a microwave and an oven and an air conditioner, there is a greater requirement of current, so the resistance should be less, and hence the wires are shorter and thicker to make a lesser resistance. And then there will be a third factor, which will be the nature of the material. Like if I ask you that I give you a copper wire, an aluminum wire, and a silver wire, all of the same length and same area of cross section, do you think they'll have the same resistance? No, because the nature of each material is different, so they cannot have the same resistance. Therefore, we would say that resistance of a conductor, which is directly proportional to L by A, combining the first two factors, I get R is equal to rho times L upon A. And when we have this rho times L upon A, what is rho? That is known as the resistivity of the conductor. And this resistivity accounts for the third factor, that is for the nature of the material. Now, how do we define this resistivity? So let's define resistivity. Before I read out the definition, I'll first show you from the expression that how we get that definition. I said R is rho L by A. So what if I say that the length of the conductor is 1 meter and area of cross section is 1 meter square? Then R is equal to rho because L and A becomes 1. So R is equal to rho. Now it's easy for me to define that. Therefore, what is resistivity? It is the resistance of a conductor, but only if the conductor is of unit length and unit area of cross section. So therefore resistivity is defined as the resistance of a conductor of unit length and unit area of cross section, and it is the characteristic of a material. So once you have found out the resistivity of a material, it doesn't matter what length, what thickness you take, the resistivity would not change. But it's going to be different for different materials. So let's look at this problem. The resistivity of copper is 1.68 into 10 to the power negative 8 ohm meter. That's rho. Calculate the length of a copper wire of diameter 4 millimeters that has a resistance of 5 ohms. So let's write down what information is given to us. The resistivity rho is equal to 1.68 times 10 to the power negative 8 ohm meter. And the diameter is 4 millimeters, which means the radius of the wire is 2 millimeters, and that would be 2 times 10 to the power negative 3 meters. Therefore, what's going to be the area of that copper wire? That will be pi r square. And the resistance is given to be 5 ohms. So calculate the length of the copper wire. So we just learnt about the relationship R is rho L by A. So we start from there. So we'll say therefore using R is equal to rho L by A. What will be L equal to? That's R A upon rho. So R times A upon rho, which means length is equal to 5 ohms times area of cross section is pi r square, and the radius is 2 times 10 to the power negative 3 square upon rho. The resistivity is 1.68 times 10 to the power negative 8. And solving this, we get 3739 meters. So that's all in this video session. In the next video session, you are going to learn about the electric power. Thank you.